Welcome to aminacademy.com. In physics, regarding sound, let us do some solving problems. Look at this example. An explosion occurs at a distance of 6.5 kilometer. 6.5 kilometer from a person. How long after the explosion does the person hear it? Assume the temperature is 15 degrees Celsius. Here, first one. The distance is given is equal 6.5 kilometer, which is equal 6,500 meter. Now, here the speed of the sound increases by 0.61 meter per second for each 1 degree Celsius. Therefore, velocity here, velocity of sound in air is 331 meter per second plus 0.61 into every degrees. Every degrees here is 15 degrees, which is equal 331 plus 61 into 15. So totally you can write directly. This one is 340 plus 340.1. Which is equal 340.1 meter per second. That means speed of the sound in air is here 340.1 meter per second. Next question. Compute the speed of the sound in neon gas at 27 degrees Celsius for neon emits molecular mass is 20.18 kg per mole. Here, the given thing is here V equal speed of sound formula gamma RT over molecular mass. Here gamma is 1.67 given for neon gas. Gamma, the specific heat ratio is 1.67 into 8314 is R. Initial gas constant R. The temperature is 27 degree means which is equal 27 plus 283 is 300 degree Kelvin over molecular mass is given as 20.18. All are under the square root by calculation, which gives 454 meter per second. Next question. Find the speed of a sound in a diatomic ideal gas. Diatomic ideal gas that has a density of 3.80 kg per meter cube and the pressure is 220 kilopascal. Here speed of the sound in a diatomic ideal gas. Here the given thing is 3.8 kg meter cube is density and pressure is 220 kPa. For this V velocity, V is given as square root of gamma RT over M. Here, you know the Gauss law. Gauss law says PV equal M by M RT. So, which gives RT over M by cross multiply. RT over M. RT over M equal P into V over small m. Then, however, rho density equal to M over V. Here, therefore, this V over M is there. Therefore, you can say V equals gamma pressure over rho, because V over M over V is M over is rho, here 1 over rho because it's a reciprocal. So we have the gamma for air is 1.4 ratio of specific heats. Pressure is 220 220, then over density is 3.8. 3.8. Let us calculate by using this calculator to 84.7. To 84.7 meter per second. That is velocity, speed of the sound in diatomic ideal gas. Next question. What is the speed of the compression wave, that is a sound wave in water? The bulk modulus of water is 2.2 into 10 raised to 9 Newton per meter cube. Here, velocity, speed of the sound in water is equal square root of bulk modulus over density, which is equal, bulk modulus is given as 2.2 into 10 raised to 9 over density of water is 1000, which is equal 1.5 kilometer per second. So far we discussed about some solving problem regarding sound in different medium. We have done. Please subscribe our YouTube channel.